Yeah, warm good morning class. Today we are going to see a most important topic in engineering materials and metallurgical field, which is iron carbon phase diagram, right? So this iron carbon phase diagram is the base or the foundation for the ferrous based industries. Means we can say in ferrous based casting, we can say this is the base for any ferrous materials dealing for foundries, right? So this is the typical iron carbon phase diagram. As you can see, we can see in a colorful way. Okay. See here, this is in x-axis they are taking carbon content percentage. We can say it is carbon weight percentage. We cannot say either it is only on carbon percentage or we cannot say it is carbon weight. It is carbon weight percentage. Then only it gives a complete meaning, right? The second one in y-axis we can have temperature in degrees Celsius, but it is here it is given temperature in Fahrenheit, but we can say temperature in degrees Celsius is more easily to remember and it will easily fit to our things, right? So here before going to this iron carbon phase diagram, this first one is ferrous carbon alloy classification. See here we can all say the materials classified metallic material, non-metallic material, but when we consider about metals, it is further classified into only two types. One is ferrous material and it is non-ferrous material. Okay, so this ferrous material is further classified to steel and cast iron mixed with carbon forms steel, and cast iron is it's a type of iron itself, not a mix of carbon, right? So a mix of carbon but on higher percentage, right? For steel, it is lower percentage mixing of carbon, but in cast iron, it is a higher percentage mixing of carbon, right? So here we can further classify steel and cast irons based upon the either the carbon percentage or an application point of view, right? So before going into the iron carbon diagram, we have to see what is allotropic transformation of purite. Means here, if for change in temperature, if a material is changing its crystal structure, then it has an allotropic transformation. Here the pure iron has an allotropic transformation. As you can see here, the change in temperature takes place. At the changing in temperature, you can see the first one from temperature to room temperature to 768 degrees Celsius. You can see it is changing from BCC alpha n to BCC alpha n, but here there is a change in shift in magnetic property. From 910 to 1400, you can see it is a gamma n, and 1400 to 1500 you can see delta n. Then out of 1500 is liquid because that is the melting point of the iron. So this same way of a typical transformation you can see in this diagram as well. You can see, so here it is alpha n, here it is gamma n, and here it is delta n, here is a liquid. As the same way, this particular alloy phase diagram is built from this allotropic transformation as well, right? So now we are going to split this iron carbon diagram into small pieces. We learn as a small thing, and we'll club together so that we can easily understand it, what is present inside the iron carbon phase diagram. So first one we are going to see is major phases, right? So here this is a loop as looks like an airplane wing or a bird's wing. You can see these are the loops which is formed. So you can see here. Here you can see this ferrite, austenite, delta n, cementite, or leave this ferrite a little bit. We'll discuss it later. So on seeing these things, you can see this ferrite, austenite, delta n, and cementite. They are the single phases, so they are the major phases. There is no combination for them. Okay. So now we can see the loops which are left over. So the loops which is left over like this loop, this loop, it is left over, right? So here this is the in this loop we can see the combination of two major phases. Means see here liquid is a major phases, austenite is a major phase. So here it forms liquid plus austenite. So here it is a combination of both, right? As like the same way, here you can see F plus A, that is ferrite plus austenite. So here, okay, and this here you can see this loop, you can see there are two phases touching this single loop. One is delta n as an austenite, so D plus A or A plus D, right? So here you can see in this phase, in this particular loop there are two phases touching. One is liquid, another one is delta n. Okay. For this bigger phase, you can see ferrite is a single phase touching and cementite is a single phase touching, that is F plus C. So this F plus C combinedly it is known as pearlite. So this ferrite and cementite combination is completely known as pearlite. This ferrous plus cementite combination is completely known as pearlite. So here it is for this particular line they have written pearlite, and we'll see an important point there in the upcoming slides. So now we can see cementite here. The cementite is seen in the line, which because this cementite is the hardest part, and it is formed on the combination of three ferrous atom and one carbon atom combinedly form this cementite, right? So this is the, we will see the rest of the combinations or rest of the split ups of this iron carbon phase diagram in the next video. Thank you.